So now in this video, we're going to look at an improved version of the voltage booster that I made in a previous video. So last video, we lit 2 series LEDs. Now we have 4 series LEDs across the capacitor. We're going to need somewhere around 10 volts for that to light up, but my power supply is set to 5 volts right there. And the waveform we're looking at is actually the voltage across the capacitor right there. So the capacitor and the LEDs. And so I have a 555 timer out there, up here I should say, and it is controlling a PNP bipolar junction transistor switch. That's a 2N3906, and that turns on, it conducts fully when the output is low, when the LED turns off, and then when an LED turns on, the transistor turns off. And so that gets current going through the inductor when it's on, and then when it stops, we get the inductive kickback to go through the capacitor to charge it up, and when it gets to a high enough charge to let current go through the LEDs right there. So I will quickly demonstrate that. I just have this cover there, and I'll turn that off. So that was just an alligator clip cover. It's the alligator clip that you could see on the screwdriver. But in any case, let's turn this over a little more. You can see there that when I get the 555 timer going fast enough, it's a light dependent resistor right there, we get enough voltage to light those LEDs. And it went off the chart there because it is above 8 volts. So that's 8 squares up. I'll change it to where each square here is 2 volts. So that's 2, 4. We're getting about 4 volts right now across the LEDs until I get the light on there. And now you can see it's a 2, 4, 6, 8, 9. It looks like about 9.5. So that's probably about the minimum it takes for them to start conducting. Now, we have to be careful. Right now, the LEDs are limiting the voltage that the capacitor will charge to. So is the oscilloscope here, because the oscilloscope only has about 1,000,000 ohms of resistance. But I'm going to pluck one of the LEDs, so at this speed it doesn't really matter right now. But when I get this going faster, you can see right there that was 2 volts. Let's get it to 5 volts per square. So we went above 16 volts. Let's go to 5. And again, I'm just doing this right now because the oscilloscope only has about 1,000,000 ohms of resistance. But there you can see we got about 5, 10, 15, and it looks like it about levels off. Let's remove the oscilloscope for a second, and hopefully it doesn't get high enough to damage the capacitor. I believe this might be able to handle 100 volts. But there you can see we had at least 5, 10, 15, 20. Looks like maybe like 23, but I don't think this quite picks up really rapid voltage changes at this speed anyways. So it's not the greatest oscilloscope. But in any case, we'll turn the light on, and I do have the oscilloscope there limiting the voltage. We'll go back to having the LED on there. So I covered this circuit in my last video, and make sure I got that in the right way. Yep. And yeah, it looks like it's just not going fast enough yet until we get the really bright light on there. There we go. Now you can see that the green LEDs are lit up right there. And so that might be conducting just a little bit that they're not lighting up. So in any case, I covered the 555 timer there. That's all that's doing. The output's going high or low. We can block this to slow it down. And so you see that LED flashing when the output goes high. There we go. And when it's low, the LED is off. When the LED is off, we have a low input there. That's a 10 kilo ohm resistor to the base of the 2N3906, and that allows it to conduct through those resistors and then that inductor. And when the output goes high, the LED is on, that turns the transistor off. That current flowing through the inductor wants to keep flowing for a little bit. So it goes through this diode, so it can only go that way, it can't come back. but it goes through the diode and charges the capacitor, which comes back to the other side of the inductor. And once we get somewhere near about 10 volts, then the LEDs will start conducting. Since we're not dealing with a ton of current, the LEDs will hold the voltage somewhere about 10 volts. So if we had more current, the voltage would go up slightly, the LEDs would get brighter, but we're trying to keep things safe. So anyways, this is just a demonstration circuit, and I covered all these topics before. I'm just combining them together. There are voltage booster little modules with everything you need on there. They work a lot better. They got a lot more current and all that, but this is still a fun demonstration circuit. So hope you enjoyed it. Thanks for watching. Check out one of the other videos that I'm posting. Click like, subscribe, the bell, and all that. Donate to Patreon if you can. I have a whole bunch of links down in the description. Check them out. I'll see you in the next video.